Hello everyone. For this assignment I picked air stripping with packed tower aeration method since it's one of the widely used methods in water remediation after extracting the groundwater from aquifer, which makes this technique ex situ. This technology is a physical process which transfers the contaminants in the aqueous phase to the gas phase for the purification of groundwater and wastewater. The air stripping tower is packed with irregular shape and inconsistent size packing materials in order to provide a high surface area, as shown in the figure on the right. As for the operation aspect, contaminated water is pumped at the top of the tower and into a liquid distribution system. Then water is distributed as much as possible to flow across the packing surface, since what we want is a lot of air-water contact. After that, the water flows through the packing surface by gravity. Finally, the clean water is collected at the bottom of the tower. As water goes down, at the same time, airflow is introduced through the same path, but in the opposite direction, which is from bottom to top, by air blower. As airflow is pumped through the tower, mass transfer from water to air takes place. We can say that Henry's law is the essential factor that controls this mass transfer method. It is used to quantify the concentration of contaminants in the air that was transferred from the water. In general, if Henry's constant of the compound is greater than 0.1, air stripping most likely works for this chemical. In terms of pros and cons, a high removal rate of volatile and semi-volatile organic compounds can be considered as the biggest advantage. It can typically achieve 90 to 100% removal rates. Since polluted water is contained during cleanup process, there's no chance for coming into contact with the water. Despite air stripping's high removal rate for volatile organics, the hydrophilic chemicals and inorganic compounds are not the best candidates for this method, since it's ineffective for them. Because this treatment method consists of several different equipments like a long tower, which is generally between 5 to 12 meters, pumps, air blower, and packing materials, it might be more costly than other water treatment techniques. Another disadvantage is falling, which results in reduction of airflow rates. Falling is caused by oxidation of minerals in the feed water, such as iron, manganese, by precipitation of calcium, and by biological growth on the packing material. The one last common issue can be air pollution. By definition of this method, as we treat our influent water effectively, we transfer the chemicals to the air, which means we pollute the air that leaves the tower from the top section. In order to resolve this issue, off-gas treatments with granular activated carbon is commonly used, which absorb the contaminant molecules present in the air. As I said earlier, there are lots of different stages and equipment in this remediation mechanism, so cost estimation will depend on several factors. However, in order to provide an insight in terms of how costly the entire process is, I would like to share the numbers that we ended up for our design project in physical chemical process of groundwater remediation class, which I took last year. Our imaginary contaminated water had 3 different chemicals in it, and its designed flow rates was 150 gallons per minute. We aimed high removal fractions for all agents, and calculated tower heights was almost 13 meters. According to these and other calculated data we had, we used EPA's drinking water treatment technology units cost for packed tower aeration spreadsheets, and we determined the major expensive items. As you can see in the table, blower, tower, carbon replacement, and packing material are some of the most expensive components. In the end, we summed up capital cost of equipment and operation and maintenance expenses, and we ended up almost $5.50 per every 1,000 gallons of water treated. Thank you.